What we're going to talk about in this video is the idea of a fraction. And we'll see there's many ways to think about a fraction. But first we'll think about the most fundamental. So let's say that I have this square. And this is the whole, we can consider this a whole. So let me write that down. This is a whole. It is a complete square. Now what I'm going to do is divide this into 4 equal parts. So with one cut like that, I've divided it into 2 equal parts. And then with another cut like this, I could divide it into 4 equal parts. So there are 4 equal parts. And now what I'm going to do is I'm going to select one of those equal parts. So let's say this part right over here. I am going to select that. So the question is, what fraction of the whole is the part that I have shaded in red? Well, it is 1 out of the 4 equal parts, right? I've shaded in 1 out of 1, 2, 3, 4 equal parts. So we write this as this fraction. This piece represents 1/4 of the whole. And there's 2 ways that you can think about this. You could view this as 1 of the 4 equal parts, or you could view this as a whole divided by 4 would get you exactly this much. Now let's do another one. And this time, let's think about how we could represent 1/8. So 1/8. Well, we could divide this whole. In this case, the whole is this rectangle looking thing. We could divide the whole into 8 equal parts. So let's do that. So here I've divided into 2 equal parts. That looks pretty good. And now I can divide each of those into 2 equal parts to get me 4 equal parts. And then if I were to divide each of those into 2 equal parts, I will have 8 equal parts. And it's not exact. Obviously, I've drawn it by hand, but hopefully this gets you a sense. So now I have 8 equal parts. 8 equal parts. And now I'm going to select exactly one of them. And that'll represent 1/8. And I could select any one of these, but I'll just do this one to show you it does not have to be necessarily the first one. So once again, this square right over here that I'm shading in red represents 1/8 of the whole. Now let's look at a few more examples where I've shaded them in ahead of time. And what I want you to do right now is pause the video and either in your head or on a piece of paper, write down, if you consider this purple thing the whole, what fraction does this red part represent? If you consider this blue part the whole, what fraction does this red part represent? If you view this yellow triangle as a whole, what fraction does this red part represent? And so I encourage you to pause the video now. Well, let's look at each of these. So in this case, for this rectangle, we have 3 equal parts, and we've shaded in one of them. So this red rectangle right over here represents 1/3 of the whole. Now over here, in this kind of pie looking thing, this circle looking thing, we have 1, 2, 3, 4, 5 equal parts. 5 equal parts, and we have shaded in one of those 5 equal parts. So this little slice of the pie, this represents 1/5. This right over here is 1/5 of the entire fraction, or of the entire pie. Now this one's interesting. You might be tempted to say, well, I've got 4 parts and then I've shaded in 1. That must represent 1/4. But remember, it needs to be 4 equal parts. And it's pretty clear looking at this that this part right over here is not equal in size to this part right over here or this part right over here. These are not 4 equal parts. So we cannot say that this is 1/4 of the triangle. So you cannot say that.
Is each piece equal to 1/4 of the area of the pie? So we have a pie, and it has 1, 2, 3, 4 pieces. So it does have 4 pieces. So is one of those pieces equal to 1/4 of the pie? Well, let's talk about what we mean when we have a fraction like 1/4. The 1 in the fraction, the numerator, represents the number of pieces. So here, 1 piece of pie. And then the 4, when we're talking about fractions, is always talking about the number of equal size. Equal size pieces. So in this case, 4 equal size pieces. So the question is each piece one of 4 equal size pieces? Let's look at the pie. I think it's pretty clear that these pieces on the end are not equal. They are smaller than the 2 pieces in the middle. If you love cherry pie, you are not happy about getting this end piece because it is smaller. It is not an equal size piece. So yes, each piece is 1 out of 4 pieces, but it is not 1 of 4 equal size pieces. Therefore, it is not 1/4. So our answer is no, 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 no. Each piece is not 1/4 or an equal share of the pie. This question says, Vera's dinner plate is divided into 3 equal size sections. Vera puts all her broccoli in one section, and then we're asked what fraction of Vera's plate has broccoli. Okay, so we have a plate with 3 equal size sections, and we know that Vera puts broccoli in one section, and we're asked to figure out what fraction of the plate that is. So we can draw Vera's plate, try to represent this with a picture. Maybe Vera's plate is a rectangle, we don't really know, but a rectangle will work as long as it has 3 equal size sections. So let's try to draw that. This may not be perfect, we can probably do that second one a little better. But this should represent 3 equal size sections on a plate. And then we know she puts broccoli in one of those sections, so let's use green, draw some broccoli. Broccoli, broccoli, broccoli. And then look at this picture and ask ourselves what fraction of Vera's plate has broccoli. Well, our fraction is going to have a numerator. On top will be how many sections have broccoli, which is 1. And then our denominator will be out of the total number of equal sections. And we know there are 3 equal size sections. So 1/3 or 1 of the 3 sections has broccoli.
I have a square here divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 equal sections. And we've already seen that if we were to shade in one of these sections, if we were to select one of these sections, let's say the middle one right over here, this is 1 out of the 9 equal sections. So if someone said, what fraction of the whole does this purple square represent? Well, you would say, well, that represents 1/9 of the whole. This thing right over here represents 1/9. Now, what would happen if we shaded in more than that? So let's say we shaded in this one and this one. So let me shade it in a little bit better. And this one and this one right over here. Now, what fraction of the whole have we shaded in? Well, each of these, we've already seen, each of these represent 1/9. So that's a 9th. That's a 9th. When I say 1/9, I could also say a 9th. So this is 1/9 or a 9th. So each of these represents a 9th. But how many of these 9ths do we have shaded in? Well, we have 1, 2, 3, 4 shaded in. So now we have a total of 4 9ths shaded in. 4 of the 9 equal sections are shaded in. So 4 9ths of the whole is shaded in. Now let's make things a little bit more interesting. Let's shade in. So here I have 5 equal sections. Let me write this down. I have 5 equal sections. And let me shade in 5 of them. So 1, 2, 3, 4, 5. We already know that each of these sections, each of these shaded in sections represent a 5th. So 1/5, another way of saying that is a 5th, is 1/5. But now how much do I have shaded in? Well, I have 5 out of the 5 equal sections shaded in, or I have 5/5 shaded in. And you might be saying, wait, if I have 5 out of the 5 equal sections shaded in, if I have 5/5 shaded in, I've got the whole thing shaded in. And you would be absolutely right. 5/5 is equal to the whole. Now what I want you to do is pause this video and write down on a piece of paper, or at least think in your head, what fraction of each of these holes is shaded in. So let's go to this first one. We have 1, 2, 3, 4, 5, 6 equal sections. 6 equal sections. And we see that 1, 2, 3, 4 are shaded in. So 4/6 of this figure is shaded in. Let's go over here. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 equal sections. 5 equal sections. And 1, 2, 3, 4 are shaded in. So here, 4/5 of this circle is shaded in. Now in this figure, I have 2 equal sections. 2 equal sections, and both of them are shaded in. So we would say 2 halves of this figure are shaded in. And once again, if 2 halves are shaded in, that means everything is shaded in. That this represents a hole. Now this one right over here, it might be tempting to say, hey, I have 1, 2, 3, 4 sections, and 1, 2, 3 have been shaded in, so maybe this represents, the red represents 3/4 of the figure. But remember, the sections have to be equal sections. And this red section is way bigger. It actually looks like it's bigger than the other 3 combined. So you do not have 4 equal sections here. So at least based on how it's drawn, you can't say that 3/4 is actually filled in.
This circle represents one hole. This circle right here represents one hole. If we know that, we can answer, what fraction of the circle is shaded in blue below? So down here, what fraction is in blue? Let's start back up here with the hole. This hole is divided into 1, 2, 3 equal-sized pieces. So it's divided into thirds, 3 equal-sized pieces. And each of those pieces, each of those pie pieces is 1/3, is one of the thirds. So knowing that, let's go down here to these ones, and let's see how many of these 1/3 pieces. Here's 1/3, another 1/3, another 1/3 shaded in blue, another one, and another one. So we have 1, 2, 3, 4, 5 thirds. We have 5 thirds shaded in blue below.
We're asked to identify the numerator and denominator in the fraction 3/4, or 3/4. So let's rewrite this just so it's nice and big. So let me just write the fraction. So we have 3 over 4. 3/4. Now, they want us to identify the numerator and the denominator. The numerator. So the numerator is just the number on top. So the numerator is the 3 right there. And then they want us to find the denominator. The denominator is just the number on the bottom. It's the 4. So if they say, what's the numerator? 3. What's the denominator? It's 4, just the number on the bottom. They could have just called this the number on the bottom. They could have just called this the number on top. Now to think about what this represents, what this fraction represents, you can think of it of 3 out of 4 pieces of a pie. That's how I think about it. So you can imagine the denominator tells us what are we taking a fraction out of, or how many pieces are there. So let's imagine a pie like this. So we could draw it like, well, we could draw it as a square pie. So we could draw it as a square pie. So this is what the denominator represents. This is what the number on the bottom represents. And then 3 says we are representing 3 of those 4 pieces. So this 3 tells us that out of 4 possible ones, I guess you could think of it, we are using 3, or maybe we're eating 3. So you can imagine someone says, I ate 3/4 of a pie. This would be read as 3/4. They're eating the blue portion of the pie if we cut it this way. If we imagine a round pie, it would look like this. Let me draw a round pie. So that is my round pie. Let me cut it into 4 equal pieces, or roughly equal pieces. And if someone says, I ate 3/4 of this pie, where the 3 is the numerator, and then the 4, and you'd read that as 3/4, the 4 is the denominator, they would eat this much of the pie. They would eat 3 of the 4 pieces. They would eat 3 of the 4. So this is 1 piece, this is 2 pieces, and this is 3 pieces. So you can imagine the 4, the denominator represents the total number of pieces in the pie, and then the 3 represents how many of those we ate.